Hey everyone, so welcome to the second Leetcode mock interview video. I would suggest that you first try this problem yourself, and then if you figured it out and you want more a better understanding of the problem, or if you got stuck and you want an explanation, then go to the explanation video and then look at this video if you want to see my thought process as I try to tackle this problem in real life, or in real time. Okay, so I'm just going to start the mock now. Okay. Write a SQL query. Okay, well, I don't know SQL, so let's skip this. Let's try that again. Data stream as disjoint intervals. Okay, this one's hard, so let's see. Given a data stream input of non-negative integers a1 to an, summarize the numbers seen so far as a list of disjoint intervals. For example, suppose that integers from the data stream are 1, 3, 7, 2, 6, then the summary would be 1, 1, 1, 1, 3, 3, 1, 1, 3, 3, 7, 7, 1, 3, 7, 7, 1, 3, 6, 7. Okay, so I just have like a list of intervals, and as I keep adding more, I would start connecting the intervals. So initialize my data structure, add a number, get intervals. Okay, so normally at this point I would say, can I have a moment to think about this? And then they'll usually say sure, so I'm going to ask, can I have a moment to think about this? So the brute force way would just have a sorted list of intervals, and then every time you have a new number, you sort of go through all these intervals, and then you try to combine them. And I guess I'm pretty sure you could somehow do this with a heap. If you're to do that with a heap, or if it was a tree and then well, let's say it's a heap and it's sorted by starting interval time. Okay, if it's a heap and you sort by starting interval time, then you try to find the interval that is less than your given number, and then if it connects, then you add it to the interval. Otherwise, you add a new interval to the tree. I guess that could work. So I guess I'll write that down. Heap sorted by starting interval, and then search for greatest interval with greatest start time less than number. Okay, and then what if I used a sorted vector of intervals? Well, if I use a sorted vector of intervals, then I would just if I use a sorted vector of intervals, I could use binary search. I could use, well, the brute force way would to just go through it one by one, or I could use binary search to find the greatest start time less than number. And then if it's less than it, then if the number is one more than the end of that interval, then I just add it to the interval. Otherwise, I would have to make a new interval, like insert that there. Then there's the case where after I add it to the interval, it also connects to another interval, and I have to connect that. Okay. So I'll do some quick runtime analysis of this. So search for the interval that's log n, and then I add it. Okay, and then that should be constant time. But then if I want to combine things, I guess the runtime of that would be n, because I could combine everything in the tree. Okay, and then so a sorted vector of intervals. So I have a sorted vector of intervals, and then I use binary search to find the greatest start time. So I think the heap would just make it like a lot more complicated. I could just use a vector of intervals. In that case, I use binary search to find the greatest start time less than the number. Then I see if I can combine it. And then after that, I would just keep combining it, right? The argument also is that, let's say I don't find the greatest start time, or there isn't a greatest start time, so then I add the interval, but then this interval, this number would be connected at the end, meaning that if my number was 5, and that was the smallest number, but there's already a 6 in my vector of intervals, then I'll have to connect 5 to 6. Okay. So what would be the cost of all of this? I do binary search. Okay, so the thing is, if I use a vector of intervals, if I try to insert an interval, it might take n to like insert, whereas a heap, it would be like log n. Okay, so how much time do I have left? Oh, 49 minutes. Okay, so the heap. So I take something out of the heap. Oh fuck! Take something out of the heap. Then I add to it. Then can I put it back? Okay, so I take something out of the heap, and then let's say I add the number to it. Do I take it out of the heap? Do I put it back into the heap? And then how do I find the number after? Because the heap is ordered. Can I even search an interval with a heap? Okay, honestly, I'm not too familiar with heaps. That's probably something I should look into. So I'm just going to use the sorted vector of intervals. That makes the most sense to me right now at this moment. Okay, so vector of intervals or linked list of intervals. Okay, at this point, it's been, I think, 15 minutes. I'm just going to start coding. I can optimize later. So I'm going to have a vector. Summary ranges. Every time I add a number, okay, well, I'm just going to return v. Every time I add a number, okay, at the end, dot sort. So I add a number. So when I add a number, I want to find so first find interval with greatest start time less than number, less than value. Okay. And then check if interval.end is one less than value. If it is, if yes, then add to that interval, else make new interval and put into V. And then we have to deal with the case where the value also connects an interval at the end. So interval at the end, I mean, you just go one over, right? So look at next interval, compare start time to current interval's end time. Oh, just compare, I guess compare to val. So we can either compare to val, or we could set current interval equal to the new interval the new interval created by val, or the previous interval that val got added into. And I'm guessing that numbers can be repeated. So actually, if interval.end is one less than val, else if end is greater than val, do nothing. So I should probably move that to the end and then make a new interval. If it isn't, and then I just sort it at the end. Okay, well, seems good to me. For now, I'm just going to do a brute force. So int index equal to 0. So I want to go to the end. While index is less than v dot size, and so find the greatest start time less than val. This seems like a tricky off by one thing, but v at index dot start is, let's say, do I want it to be less than or equal to, or just less than? Okay, well, what if it's equal? Okay, I'm just going to do less than for now, but not sure. So let's start as less than val, then index plus plus okay, so let's think about it a different way. I want index to be the index of the number that the greatest start time with less than val. So oh man, so maybe I should start at the end then and go backwards. Yeah. This is so messy. Size -1, index minus. So while index is greater, or while index is okay, this video, I'm going to put a warning at the beginning. It's not going to be a good video. All index is greater than 0. And via index of start is greater. Right. Index minus. So at this point, either index is equal to 0 or at this point either index is greater than 0 or we have the index of the interval with a start time that's less than or equal to val. Okay, so yeah. Now, if we just check if interval.end is 1 less than val. So at this point, say we have 5, 6, 7, 8, 9, and then our number is 4. So we arrived at 5. So 5 is greater than 4. Oh my god. Just so you know, if I got this question as an interview question, I probably wouldn't pass the interview at this point. So check if interval.end is 1 less than that. Okay, so I have the index. At this point, index is equal either 0 or the start time is greater than the value, or less than or equal to the value. I'm just going to code. At this point, I'm just going to code and then deal with edge cases as they arise. So if so if I so v equal to val minus 1. If that's the case, we could just add this index to add this val to the end of index. So v index dot end equal val. But then we have to make sure that if this connects it to the next interval, that that's taken care of. Otherwise, so else else if the end if index the end is less than the val, then we have to make a new index and put it in, or make a new interval. So interval new interval equal interval, and the start and end will both be val. Is that the right API? I think so. And then yeah, we still have to make sure that if it connects at the end. Else Okay, so we took care of the case where the end is 1 less than val, which means we just add it to that interval. Otherwise, if the val is greater than n but more than 1, then we make a new interval. Now, what if interval is less than what if val is less than interval dot start, like the interval at this index dot start? Okay, so in that case, index would be -1 over here, because the start would be greater than val, so index would go minus minus. Okay, in that case, if index is equal to -1, that means it's at the very beginning. So okay, so we took care of that case. Now what if so let's say 4 is the val. And in this case, let's say it's just right. And then let's say it's not just right. Okay, and then in this case, otherwise that means that it's like inside, so we just don't do anything. Now we look at the next number over to see if we connect it. This code is so ugly. Alright, well, I'm just going to do this in this statement because we have to deal with it differently in each case. So if I change the end, then I just look at the next element, if there is one, and see if I can connect that. And then every time I find a new one to connect, I have to remove it from the vector. So while So while v.size, so if this keeps running, I'm going to have a return in here if what I want breaks. But if it keeps consuming the next interval, actually no. All I have to do is look at the next interval, because I'm assuming that everything past the interval will be connected correctly. So once I just look at the next interval. If I can connect it, then I connect it. If I can't, then I just stop. Or if I can, then I connect it and I stop. If I can't connect it, then I just stop. Because everything past that interval already is for sure connected or not connected. Yeah. So I just check. If index, if v.size is greater v.size -1, so v.size -1 is the greatest index, is greater than index, meaning that index or if index is less than v.size -1, meaning there's one more than index in v, then we check. If so we have that, and then and v at index, so we just added val dot end, which is now val, is equal to v at index plus 1 dot start. So now if they're the same, then we can connect it. Otherwise we don't do anything. So if we want to connect it, then v at index dot end will equal v at index plus 1 dot end. And then we want to remove v at index plus 1. So v, I think it was erase index plus 1. I'm not sure if that's the right API. C++ vector erase. Iterator. Okay. I see. So v.begin plus this. Okay, so that should erase, so that should handle that case. Now if now for adding a new interval, we can make a new interval, or we could check if we could just extend the one after. You'll see what I mean in a bit. So we do the same thing here. So we see if we have one more element in V, then we instead of looking at v at index.end, we look at val is equal to okay, actually we want to make this -1, meaning that we want to connect it, not see if it's equal. So we can do that. And then instead of setting the ends, we just set v at index plus 1's start equal to val. Otherwise, if that's not the case, then we have to make a new interval. How much time do I have left? 18 minutes, that's still plenty of time. Let's now have a new interval. Okay, the thing is, I think I had an hour to do this. Most interviews are 45 minutes long, which means I would have already run out of time in a regular interview. So I just have to add this new interval into the vector. So if there is a new interval, then v.push back new interval. So I put that in and then I sort it. Okay, so this is my rough draft. And before I run it, I'm just going to explain the code again. So V is a sorted vector of intervals. When I add a number, when I add a number, I first try to find the interval with the greatest start time less than that number or value. So I start from the end, and then I keep decrementing the index as long as the index is greater than or equal to 0. And the start of that index is greater than the value. So at the end, when the start is less than or equal to the value, then I know it's the greatest start time less than the value. Or if index is equal to -1, it means that there's no interval whose start time is less than the value. Then I make a new interval and I first check if it's -1. If it's -1, then like I said, there's no interval less than this value, so I just make a new interval out of this value. But what if this connects? So if it connects, then I have to add it. So yeah. This is if statement soup. If else statement soup. Okay, so this is pretty much the logic I'm doing here. Okay, I'm just going to copy and paste this code, and then I can refactor later. If index if first empty v, if v is dot empty v dot size equal to 0, then easy, I just make a new interval, interval equal interval val, and then v dot push back new interval return. Okay, so now I know for sure there's at least one item in this vector, so if v at 0 dot start is equal to val minus 1, then val at 0 dot start, v at 0 dot start will equal to val, else I have a new interval. Okay, so if that isn't the case, that means there is an interval in v whose end is less than val. So we first check if it's 1 less than val, that means we just have to update the end of that element. So we set it to val, and then afterwards we have to see if this connects to the next element. So if there is a next element, size minus 1 is greater than index, then we check if the end is equal to the next element's start minus 1. If it is, then we connect it. So n equals so many mistakes. Oh no, actually no. So we set the end to the next element's end, which basically connects them and combines them into one interval, and then we erase the second interval. Now if the end is less than val, but the difference is more than 1, that means we have to make a new interval. And except in the case where there is a next interval and this val is 1 less than the start of the next interval, in which case we just put this new value into that next interval. And then The final case is if val is already in an interval, in which case we do nothing. And then if there is a new interval, we want to put that in and then we want to sort it. And then if we want to get the intervals, we just return v. Alright, praying this works. Tuple, line 63. Oh shit. Can you not do it? Sorry, I haven't coded in C++ in a while. This is C++, right? Not equal to null. Please subscribe to reduce wait time. Operand types are interval. Okay, well, I'm just gonna make this a pointer. Please work. Why? How much time do I have? 8 minutes. Okay. I'm gonna get this to compile. What's wrong? I have a pointer. That's a new interval. I set that pointer. Pushback, vector, pushback. I'm dereferencing. Okay, maybe interval blah equal star new interval. Then vector push back. Wait, why can't I push back an interval? Dereference pointer. Yeah, what? Okay. Desperate times call for desperate measures. Interval. Start. Oh, line 27? Okay, just leave that there, but Oh, okay. What? Sort V. Sort vector. I know you have to sort vector begin. Okay. Sort v dot begin, v dot end. Oh my god, what the heck? Five minutes left. What? Sort C++ vector. Okay. And we probably need like a sorting function. So pull my function. And then we have interval I, interval j, just return I dot start and I j dot start. Please work. What? You gotta use a non-static member function? Non-static. Static. Double free or corruption. What does that even mean? Double free or corruption? Oh man, what a disaster. And now again. Okay, well, I guess this means that I at least pass the easy test cases. Double free or corruption. Double free or corruption. This is very strange. Okay, well, at this point, basically both me and the interviewer both know that I probably wouldn't pass the interview. and we talk about life or something. Okay, well, I don't know if you guys, ladies and gentlemen, if all of you stayed with me to the end. This question was pretty hard, in my opinion, and if I got this on an interview, I would probably just cry. Just kidding. I would try my best. If I were to review my performance on this, I guess I got kind of confused and didn't really know where to tackle the problem. I spent a lot of time planning out what I should have done, like with the heap and with the sorted vector. I think that learning from this experience, like if this was a mock interview, what I would definitely take out, or if this was a real interview, what I would take out of it was I definitely need to like learn about how to use heaps so that I could more easily figure out if I could use the heap or not here. And I should probably do more problems so that I can gain this intuition as to what to do. Now, sadly, I don't have that intuition at all at this point, so I didn't pass this one. Yeah, but this happens, right? And I'm going to upload this even though I kind of failed at it, because I want to show you guys that it's very normal for even people like me, even though that's like not much of a statement, but again, I've had a few internships, yet there are a lot of problems I can't solve, and I think that's okay. So I'm going to now do some research on this problem and try to explain it. So I'll definitely get something out of it and learn, and I hope you will learn from that too. Alright, thanks so much for sticking to the end, and I'll see you in the next video, I guess. Bye.